Hi, today we're going to look at exponential functions and how to solve these equations. So just remember your exponent rules because we are going to be using them, which are here for you. So what we're going to do, I'm not sure why that appeared, but so when our goal, when we're solving these exponential functions, we are trying to get our bases here to be the same, so that way we can go ahead and set the exponents equal to each other, and then we're just going to solve for the variable. So for example, 2 to the x is equal to 64. So they don't have the same base, so you want to go ahead and change 64 with base 2, which is 2 to the 6. Now notice that the bases are the same now, so we can set the exponents equal to each other and solve for x. X is by itself here, so we are good. Notice on the next one, the bases are not the same, so we're going to go ahead and change 27 to base 3, so that would be 3 to the third. This is where your exponent rules come in. Remember, a power to a power, we multiply. So I'm just going to add a step here so you see what we're doing here. So 3 to the 2x is equal to 3 to the 3x minus 12. Okay, because we're going to go ahead and distribute here. Now the bases are the same, so we can set the exponents equal to each other, and then we're going to go ahead and solve. So we're going to move the 3x and then divide, so x is equal to 12. So it should be a pretty easy lesson. All we're doing is using our exponent rules and then using our algebra skills to solve for x. So again, our goal first is to change the bases to be the same. So I'm going to change the 9 to 3 squared. Power to a power, we're going to multiply. Now that the bases are the same, we're going to set the exponents equal to each other, and it's solved. That is your answer. Let's try the next one here. So the next one here, notice the bases are not the same. So I'm going to change the 4 to a 2 squared. Do the power to a power rule, which was 4x minus 2. Now that the bases are the same, we're going to set the exponents equal to each other. And we're going to solve the linear equation. So we're going to move the 4, so x is equal to negative 2. Okay, let's go ahead and practice some. Notice here, the 3's are the same, so I can just set the exponents equal to each other, which would be 4 there. Let's look at the next one. The bases here are the same, so 1 is equal to 2x minus 3. I'm going to add 3 and then divide by 2, and that would be your answer. Let's try the next one. Well, the next one, the bases are not the same, and I cannot write 27 with base 9, so I'm going to look for another base that they both can have, and that would be 3 to the second. And we can write 3 to the third on this one. So this would be 3 to the 2x plus 4, and this would be 3 to the 3x. Now the bases are the same. We can set the exponents equal to each other. So we get 4 is equal to x. Okay, let's try the next one. Notice the bases are the same. So we're going to set them equal to each other, and we're going to solve this linear equation, just like we did back in pre-algebra and in algebra 1. Now, in the next one, we have to be careful. This is a half, and this is a 4. So I'm going to use this one, and I'm going to change it to 2 to the negative 1. And this is one way to do it. And I'm going to change the 4 to 2 to the 2. So this would be 2 to the negative x. And this is the negative exponent rule right here. Remember, if it's a half, I can change it to 2 to the negative 1, which is equivalent. And the bases now are the same, which is what I wanted. Negative x is equal to 2. I'm going to divide by negative 1, so I get x to be negative 2. Let's look at the next one. Again, the bases are not the same, so I'm going to use the base to be 2. So I'm going to go ahead and write the bases to be the same here, which they are. So 2x is equal to x minus 3, and I'm going to solve the linear equation. I'm going to go ahead and move that, and we get negative 3. So we did good there. Okay, let's try one more set, and let's look at this one. Now notice I can 1 over 64 and 4, I can rewrite this one as 4 to the negative 3. Okay, now that the bases are the same, I can set this equal to each other, And we're going to move it so I get -4 there. Let's look at the next one. Again, I need to change the bases to be the same here. So x is equal to 3 because 125 is 5 to the third. Now, it's very important that you know your squares and your cubes. The squares you should actually know from 1 through 13, and your cubes, okay, so for example, x squared and x cubed, okay, you should know at least 1 through 7, like 1 cubed, 2 cubed, 3 cubed, all the way to 7 by memory. Let's look at the next one, 3 to the 2x, and this is going to be 3 squared and raised to the 5x minus 4. I am going to use the power to a power rule, so I get 10x minus 8. Now that the bases are the same, I can set 2x is equal to 10x minus 8. I'm going to move 8 to the other side and 2 to this side. So x is equal to 1. Okay, so far so good. Let's see if you can pause the video and do the next ones. Okay, so hopefully you were able to do it. This becomes a 5 to the 2. And this becomes a 5 to the third. So we get 5 to the 4x and 5 to the 3x plus 30. Now the bases are the same here, so we get 4x is equal to 3x plus 30. And we're going to get x is equal to 30 here. Okay, let's try the next one. Okay, the bases, we need to have them the same, so I'm going to change this one to 2 raised to the x and 2 to the -1, because they do need to be the same. So 2 to the 2x, 2 to the -x plus 3. Don't forget to distribute. Now that the bases are the same, we're going to go ahead and get 2x is equal to -x plus 3. Add, so we're going to get 3x is equal to 3. X is equal to 1. Okay, let's look at the next one here. This is 3 to the -x. I'm going to do 3 to the -3 here. So I get 3 to the -x, 3 to the -6x minus 15. Now, the bases are the same. -x is equal to -6x minus 15. I'm going to move the -6x to the other side, which becomes 5x. And then I'm going to go ahead and divide, and we are going to go ahead and get -3. And that is the lesson. And you can always go back and check your work. You can plug it back in and see what you get. And they should be equivalent to each other. Okay, good job.